So this video is dedicated to Kevin, and I want to talk about kinematics. Kinematics. Well, the first question I asked was, what is kinematics? And if you were to guess, maybe the matics looks like mathematics, informatics, and maybe the studying of something, and kina is like kinetic, kinesthetic. So like again, these are moving or motion. So studying of moving, study of motion, study of moving bodies. So it's actually misleading if I say bodies, because we really think of everything as just a point, okay? So just the study of moving points even. Motion, and in particular in the definition it says something like without referring to forces causing the motion, which could be kind of confusing if you don't know what forces are. And but maybe without referring to forces causing the motion is maybe just sort of further emphasizing that we're studying just moving points. So we don't care about how heavy the objects are, how big they are, and if they're moving because they were hit or for some other reason. Okay? And you know what really is fundamentally is moving. You know, moving is related to an object's position. Okay? And so an object has position, and it has change, and its motion is how it changes position over time. And maybe we could see how the motion's changing, so the change in this over time. So motion means change in position over time. Okay, so there's more familiar words that kind of describe these things. But they actually mean they don't mean very different things, but they're much more precise. They have much more precise meanings in physics than maybe in everyday life. So we were talking about distance. So the position, you know, is really just a measure or some distance away from, you know, the x-axis, the y-axis, and the z-axis. So the position is very closely related to distance. Change in position is like the change in distance over time, speed, and how speed changes over time is acceleration. And to get even more technical, we have the words displacement, velocity, and acceleration again, which is slightly abusive, and they mean different things to distance, speed, and acceleration. Namely, these are vectors when the originals are scalars. Okay, so vectors means that they have not just a magnitude, they also have a direction. So actually a displacement is just a distance together with a direction in which the distance is gone. Okay, velocity is a speed together with a direction in which the speed is occurring. Acceleration is a change in not just the speed, but also possibly in the direction of the moving object. Okay, so we went through an example where in a car, you know, you accelerate by pressing the accelerator because that changes your speed, but you actually also accelerate by pulling the handbrake or pressing on the brakes, because that changes your speed as well. It just decreases it. Okay, And you also accelerate when you turn the steering wheel, because you're changing your direction, which is changing your velocity. Okay, so you're changing the direction of your speed, so you're changing your velocity, and so you're actually also accelerating. So everything you do in the car was accelerating. Okay, so we'd appreciate. And then another way of thinking of kinematics is it's really the study of these three vectors for a given object. So it's studying its displacement, its velocity, and its acceleration. If you've done calculus, or maybe you could review this when you've done calculus. If displacement is s, maybe we could keep it. Maybe we could fix a direction, okay, and just let s be the magnitude of the displacement to make it simpler. But the relationship between displacement and velocity and acceleration, okay, at least their magnitudes when the direction is fixed, is that they're the derivatives of each other with respect to time. So you get from that to velocity by dv dt, and you get from v to a by dv dt. Okay. And then we should talk about sort of, if you have a point, okay, in space, and that's exactly where it is, you know, you could watch how the point changes over time and you get an idea of where it is for the time, okay? But how would you know where the point is in the future? Okay, so if you see a pattern in the past, maybe there'll be a pattern for the future. But at a point itself, you might not know where it's going to be in the future if you just know its position. But if you know its velocity, okay, so you know like a direction that it's going to move, then in the immediate future you know that its position is going to be somewhere in that direction. So, and you could probably calculate it using its velocity, or approximate it using its velocity. Okay. And then, so if you knew its velocity all the time, but you only knew its position currently, then you should be able to figure out its position all the time as well. Similarly, because the relationship between velocity and acceleration is the same as the relationship between displacement and velocity, if you knew how much it was accelerating all the time and you knew how fast it was going at one moment in time, then you'll know how fast it's going in all moments in time. Okay, for the same reason. So actually, if you knew its acceleration for all moments in time, and you just knew its position and its velocity currently, then you would know its position and velocity for all moments in time. Okay, that's the kind of reasoning. So this is the kind of this is the reason why we're studying displacement, velocity, and acceleration like this. Okay, so if you know how A behaves in the future, and you know V and S now, okay, then you also know the future V's and the future S, okay? So if you know how the object is accelerating and you know where and how fast it's going, sorry, where it is and how fast it's going, then you'll also know where it'll be in the future and how fast it'll be going in the future. So if you actually just knew something about its acceleration, you could guess, like right now, you could guess a moment in the future on its velocity, which will tell you also a little bit about the position. Okay, so that's an introduction to kinematics, and then we'll look at the equations of motion next.